Hi there, I'm Ian Gibson, and this is lesson number 2 in my series of series circuits. Today we're going to be talking about Kirchoff's voltage law and series circuit formulas. This is the same circuit that we looked at in the previous lesson, and you'll see that we have 120 volts and then we have some resistances, and each of these is what we might consider a load, okay, or a resistor. And at each of these resistances, we're going to see a volt drop. Now, I'm going to assign a polarity again, negative to positive. Remember electron flow, that the current is going to be flowing in this direction. And that's going to be our I total. And then over here, we have a source, and the source is known as our E total, okay, the voltage total. Excellent. Now what we need to do with these rules is figure out what our I total is, because we have all of the other information, so we can figure that out. Kirchoff said that for every volt drop, and there's going to be 3 of them here, one at R1, one at R2, and one at R3. Those 3 volt drops are going to add up to the source. That looks like this. E total equals E1 plus E2 plus E3, and so on and so forth. Excellent. Now, after we look at the voltage law, there's a couple more laws we want to look at. In a series circuit, the resistance is at R1, R2, and R3 equal the resistance total. So now we're going to do RT equals R1 plus R2 plus R3, and so on and so forth. And that will give us our resistance total. There's one more that we want to look at. What did we forget? Current. Now, there's something special about current in a series circuit, and that is it's unidirectional. The current is unidirectional. It only goes in one direction. And wouldn't you agree then that the current is still going in the same direction all the way through this circuit, okay, back to source. Now, if we have all of our current going back to source, that tells me that no matter where we are in this circuit, the current is always the same at each resistance. Every time it hits that resistance, it's the same. So now we're going to do IT equals I1 equals I2 equals I3, and so on and so forth. Now that we have all of these basic series rules in place, we can take them and analyze our circuit, our existing circuit. We can't figure out I total yet, but we do know E total, and we do know R total. If we take R total, we are going to add resistance 1, resistance 2, and resistance 3 together. In this case, resistance total equals 6 ohms plus 12 ohms plus 16 ohms. Let me grab my calculator. I mean, I trust myself, but I don't trust myself enough. So 6 plus 12 plus 16 gives me 34 ohms. That is my resistance total. Excellent. RT. Now, do we know our E total? Absolutely, it's 120 volts. But do we know what the voltage is at each of these 3 points? Not yet. We need to figure out I total. Once we have I total, we can figure out what that number is that's going to be through the whole circuit. Every resistor is going to experience I total. Now I think it's time to figure out what the I total is for the circuit. We know the R total and we know the E total, so now we can use Ohm's law. I, or current, equals the voltage over the resistance. And in this case, we know what our voltage total is. It's 120 volts. And we know our resistance total, which is 34 ohms. Now I'm going to grab my trusty calculator and I'm going to type in 120 divided by 34 and I get my I total, which is 3.529 amps. Well, what does our rule here tell us right away? I total equals I1 equals I2 equals I3, which means that this amperage is being experienced at every point in this series circuit. So I'm just going to copy that down. I'm going to write I1 equals 3.529 amps. I'm going to do it over here. I2 equals 3.529 amps. And finally, I3 equals 3.529 amps. Now, we can solve for our volt drops. And that's going to be in our next lesson where we analyze a circuit and we're going to break it down from beginning to end.